All right, so we are recording. What I want to do today is take a step back and talk a little bit about your projects and talk about them with respect to what I think elevates okay project to a really good project, right? First of all, you got to get the database design right. All right, for anything to work well, that's the foundation. So if you have any questions at all about the database and how it should work and how it should be structured, please ask me. And that'll be one of the big things that I'll look at when I go to grade your assignments. The other thing, so that is necessary to even have an okay project to get your database down. Now, what elevates it from an okay project to a really good project is keeping in mind what our job is here. You know, we are in CISS, Computer Information Systems. Sometimes we call, sometimes we talk about IT if we talk about this field, if we give a title for this field, information technology. Back in the old days, like when I was first starting out, oftentimes the term used was data processing. And that has kind of disappeared. And I think one of the reasons for that is because there's really a difference between data and information. And the goal of these computer information systems is not merely to process data, but to provide information. I found this good slide online that looks up and shows the difference between data and information. Data is raw, unorganized facts that need to be processed. Data can be something simple and seemingly random and useless until it's organized. Information is when data is processed, organized, structured, or presented in a given context as to make it useful. It's called information. All right. I'll give you an example. Let's say a company had $30,000 profit last year. Is that good or bad? No idea, right? If the company is Joe down the street who started a t-shirt business, he's making, to supplement his regular income, and he's making $30,000 extra a year in addition to his regular job, that's probably doing okay for Joe, all right? That's probably a very successful year. On the other hand, if it was a large organization, if Microsoft or Apple only showed $30,000 worth of profits in a year, that would be not very good news. All right. So to make that $30,000 profit meaningful, we have to look at a number of factors. You know, how big is the company? What is the company's total value? You know, what is the company's expenses? What is the company's revenue? How well did the company do last year? If it's Joe's t-shirt shop, maybe it went from $5,000 last year to $30,000 this year. Hey, that's great news for Joe. He increased his profits 600%. So he's popping the cork on the champagne or sparkling grape juice to celebrate. Now, if it was, again, a large company that previously in previous years made millions and they made $30,000 in 1 year, well, then people are getting fired. You know, the CEO and the people in charge are probably going to be going to have something to explain to the shareholders and so on. Now, what are ways that we can transform data into information? Because that's really what information technology is. We're transforming the data into information. Well, first of all, we have to accumulate right data. All right. So we have to make sure we have accurate data. All right. we have to make sure we have the right data. And this is where it gets into the database design. But assuming that, we'll start with the assumption that we have accurate data and we've designed our database correctly. What are some of the ways that we can transform data information? One way is filtering. Let's say I am a credit card company and I'm the manager of collections, let's say, of this credit card company. If I saw a list of everyone that has a credit card and how much they owed, that's not going to do me much good. It's going to be a list of millions of people, right? If, however, we filtered and only showed the people that were more than 90 days late on their bill, then maybe you can do something with that information. So filtering, looking for exceptions. Is one way that we can take that raw data, that pile of raw data, and to transform it into something useful. That is information. Comparing. Let's say I have a series of gyms. I open up a series of gymnasiums across the state or whatever. If I'm looking at profits and losses for those gymnasiums, I feel so old-fashioned saying gymnasiums. I should have just said gyms. If I'm looking at profit and loss for those gyms, I might compare it to what the profits and loss were last year to see, are profits going up or are they going down? I might compare two gyms with each other. Like maybe a gym in Cleveland is doing really well, but a gym in Cincinnati isn't making a profit. Well, maybe I'll look to see and study like, well, why is Cleveland making a profit when Cincinnati doesn't? Are they marketing better? You know, do they have better facilities? And so on. But by comparing different things, all right, we can come up with some good information. So comparing things, filtering things, combining things. All right. How could combining things work? Well, I have a store, right? I might combine my sales data with, let's say I have a small bar, let's say in Cleveland, downtown Cleveland. I might combine my sales, my daily sales combine it with the Cleveland Browns schedule. How much more do we make when the Browns are in town? Do we make less, God forbid? But by combining data, by organizing data. Maybe, again, getting back to our health club, maybe we organize by region to see what region is doing better than another. There's one more I had. Let me think about it for a second. Oh, summarizing data. Maybe I don't need to see all the detail of transactions in the database. Maybe I need to summarize and only show me the bottom line or the total of stuff. Maybe I'm not interested in the salary of each individual employee, but I want to see the total salary of all my employees. So I'm going to summarize that by for all employees. Then maybe I combine that with last year. I organize it by region. Actually, I meant to say comparing to last year. And combining it with the sales numbers. So maybe we're paying more money, but we're getting a lot better sales from our organization. We'll know that if we combine our salaries and sales figures for a period of time and compare it to last year. Then maybe we filter it out and only pick the ones that the parts of the organization that are underperforming. All right, so what is this all about? This is all about getting back to your project. Most of you by now, I trust, can go and make a database table, create the model, create a database table, scaffold it to get CRUD operations, CRUD, create, retrieve, update, and delete. And maybe, for example, you might get pages that look like pages that look like a good one, this. Or this. We can even see how we're allowing for filtering here to make this more useful. Or this. I assume you can make these simple scaffolded pages and do a create page, retrieve page, and delete. What about combining the data in different ways, or filtering the data, or summarizing the data? That's what I challenge you to do in your project. Look for opportunities to give us more than just the basic CRUD functionality. That's needed, but that's not really what makes a project like really good. So I have an example that I want to go over today that sort of attempts to show you what I mean. Under courses, I have rosters. That roster combines for a given course, the name of the course, the department it's in, the instructor it's in, and a list of all students. In the old days, they used to print these out and give them to the professors. Maybe some places still do that. There's room for 2 professors here. Actually, there's room for unlimited professors, but this one happens to have 2. I came up with the data 2 different ways. The 2 different ways correspond to the 2 different ways that you can write LINQ statements, LINQ. Oh, let's do better than this. We talked about this last time. Let's use ChatGPT. multi-factor send a notification. Let's get it. Oh, am I trying to sign in? Yes, I am. Okay, there we go. All right, standard disclaimer. I have lots of fun with this, by the way. You should too. I know I shouldn't tell you what to do, but I ask it questions from all different aspects, and I ask questions to try to trip it up, and it's a lot of fun. Okay, what are two ways? I've gotten angry at it and told it to shut up and things like that, and it's like it responds so passive aggressively, like, sorry if I upset you. What are two ways to write LINQ statements in ASP.NET? First one is called the query syntax. And here's an example of it. Let me try to make this a little bigger. Not working. But some of you probably had CISS243. In fact, that might be a prerequisite for this course. And you probably had to write some SQL statements. A couple of people that are here, is that true? Did you have to write SQL statements in 143? Don't remember? Okay. Well, if you did, if you know how to write SQL, like a lot of old timer programmers know how to write SQL, all right, the first way of writing LINQ statements is using query syntax. This code is very similar to the code that you would write in SQL, standard query language. It's just a few things rearranged a little bit, but basically it's the same. We have the from clause that says where we're going to get our data. We have the where clause that tells us how we want to filter the data. We have our order by that shows us how we want to sort it. And then finally, we have the select statement that tells us what it is that we want. If we were writing this in SQL, we'd probably just basically rearrange these things and make maybe a couple other handful of changes. The other way is through a series of methods. Whereas we want a query that is going to be from the products page, where order by select this. I think you can see by looking at this that these two look really similar and they would produce the same results. Interestingly enough, both are interchangeable, and you can mix and match if you want to. You could do part of the and you know, I don't know why you'd want to, but you know, I would hope that you at least have a passing familiarity with both. Pick the one that you like better. Personally, I like the query syntax better. I think the query syntax was put in for those old timers that love to write SQL statements. That would be my guess. Anyhow, this roster I've created two different ways. Two versions of the roster. This way and this way. First one is with the method example, the second one is with the query example. And notice that we are getting essentially the same thing in both of them. All right, so let's take a look at it. Let's look first at the at the method example. It's just a small thing that you can do to produce useful information instead of just raw data, spitting out and, gathering and spitting out raw data. So consider what your project opportunities to do this. So let's look at the roster page, and we'll look first at the CS page, and then we'll look at the Razor page. All right. We have here a course. This is a roster for one course. So we don't need a list of courses, we just need our one course. On get, we better be passed on the query string an ID. If we're not passed an ID, then we can't possibly pull up the course that we want. So we display that the data is not found. Now, here is with the method syntax where we have a chain of commands that are forming this one course, this course object. So the first thing we say is await context courses. That's going to give us all the courses that are in our database to start. All right, we're going to whittle that down and we're going to fill in the gaps. So in terms of the model, what that does is fills in all these attributes for a given course. And why do I say a given course? Because the very next thing says, I want a where clause where the course, for the course ID matches the ID that we've entered. So at this point, if we were done, we would have the course model filled in with everything except these things, because these things are in related entities, in related tables. So it doesn't automatically fill in the related entities. We have to tell it to do that. And that only makes sense, right? A table can be related to a bunch of other tables, all right, in a large database. And we wouldn't necessarily want to fill in that tree with every possible connection that a piece of data has, all right? We want to tell it what pieces, what connections are relevant for what we're trying to do. So in our case, we want to know the instructor, we want to know the students, and the department. So we want to fill in the enrollments, the department, and the instructor object associated with this object. So doing this just gives us the course part of that model. Gives us all the attributes, doesn't give us any of these related objects. But we're going to tell it that we want them by saying, first of all, include the department that's relevant for this course. Effectively, what that does is that fills in and puts in that course object that we're creating. It fills in the department object. So now we have all the things that are associated with the object plus the department object. We do the same thing for instructors. We do the same thing for enrollments. But for enrollments, we have to take it one step further. Because if we fill in enrollments, we have this information, and we want to fill in the student information. So I say, then include student. When I say then include, what I'm saying essentially is, give me the students for this enrollment record. So when I just say dot include, I'm filling in lists and objects in the course object. When I say this, I'm filling in the student that's in the enrollments. Now, I have a little bit of redundancy here in that I filtered this two different ways. And fortunately, I said the same thing, but we could get rid of one of these. I get rid of that. And still produces the right answer. I say give me first or default because, well, we know since we're retrieving by primary key, there's only going to be one that matches that ID. Notice we're getting the ID passed on the query string for it, so we can retrieve it. If we were to go in and not put anything in for the queries for ID, then we get that you can't find that page. This was me experimenting. So you can disregard that. And you can disregard this. So what we have after this statement runs is we have a course object that is in the model, and it's called course. It contains filled in a department object, a list of instructor objects, a list of enrollment objects, and each enrollment object has the student's data filled in for it. So let's turn our attention now to the Razor page. All right, what do we display here next to course? We're pulling from the model, the course object in the model, we're pulling the title. So we're pulling title. That's in the course object. That's in the model. Model.course means the course object in the model. That is this one right here, same one we filled in a minute ago. Now, I want to display the department. So what do? I use that dot notation. The course only has one department. So there's not a list of departments associated with the course. There's a single department object. So I say in the model, look at the course object. Look at the department object that is part of the course object and give me the name of the department. Just for fun, let's do this. I got rid of the include departments. Let's see what happens. Doesn't know the department. Why doesn't it know the department? Because we didn't fill in the department. That's what that include tells us. Couldn't decide if it was going to give us an error or just not display anything. So now we're saying include the data from the department so we can, that department object that's part of the course gets filled in and we can display the department name. Now instructors is a little different because instructors can actually have multiple instructors per course. All right. Why is that? Well, if we look at the course, there's a list of instructors associated with it. We look at And there's a list of courses associated with each instructor. That is the many-to-many relationship that is created. It gets implemented as a intersecting table that we talked about when we discussed many-to-many relationships. At any rate, we're going to loop through each instructor that's assigned to that course, and we're going to get from the model course instructors, so the list of instructors associated with the course object that we retrieved in the model, we want the full name. So item is a row or a member of this list. We want that member's full name. And we put a non-breaking space after it, just for good measure. Finally, we do sort of the same thing with students. We look through all the enrollment records. Since we filled in the student associated with the enrollments, again, because we said then include, it's filling in something in this object. Because we did that, and we can ask for that enrollment records student. If I didn't fill it in, it would know that there were a certain number of enrollment records, but it would not know the name of the student because we didn't fill in the student object. And that is how this works. Now again, I'm not saying this is something earth-shattering. It's beyond a basic just display the row, all the rows of data in the database, display all the rows in the database, allow me to insert, retrieve, update, and so on. I actually see a list like this when I go to enter grades. So if I were to log on the instructor portal, I'd have a list of my courses. If I clicked roster, it would show me all the students in that course, along with a place for me to put in their grade. So instead of me having to go in some other way and assigning a grade to a student some other way, I could assign a grade to a student by having a whole class roster. I put your grades up in a nice spreadsheet. Both are in alphabetical order. I just go down the list. So this could be a start of that page if we put something, put more stuff into it. Okay, let's look at roster number 1. Same thing, except using query syntax instead of the method syntax. Let me close all these. Notice something that I can maybe make a little more efficient in this, and I'm going to try it out after I demonstrate what I'm doing. Let's pull up Master 1 model. All right. First part of it's the same, right? Now in this case, I'm dealing with an individual course, so I am pulling up, I'm actually doing this a slightly different way. I'm going to try to rewrite this to do it, but I did it this way, and it's not a horrible way to do it, but I think we could do it a little cleaner. All right. From C in context courses. That's the table we're getting it from. Where, the where clause. what do we want? We want title. We want a department and a department name and an instructor. And I go and I fill in the title. Well, we'll skip that. I then go and pull up a list of enrollments along with their students. Notice this syntax actually does some assumptions and assumes that we actually want data in the student table, and it fills it in for us automatically. We try this a different way. This is live coding. See if it works. Oh. Why this is. tell you what, forget this. I'll come up with the answer and you can review it next week. I think there's maybe a more streamlined way of doing this though. So we populate this variable course stuff. It's going to contain a title, department, and a list of instructors. We then populate this thing called student stuff, that it's a list of students' full names. And then we fill in those model fields, course name, department, and instructors. And we add to the student list the student name. You know, I'm going to edit this video to remove the little digression. All right. Let me go over just this part. All right. This is the first time we're going to go over this code. We haven't done it before and messed it up, so I had to re-record it. All right. On get, same as before, we look to see if the ID is null. If the ID is null, we can't pull it in. We have these variables that we're going to fill. We have a list of instructors. We have a list of, we have a string for department name, a string for course name, and a string for the student name. This is written in the query fashion, which means it looks very much like a SQL statement. We're creating this sort of temporary object called course stuff that's going to have a title, a department, and an instructor. Whereas the title is going to be the title from the course. The department name is the name from the department associated with that course. And the instructors is that course's list of instructors. It should only get one of these, but we're going to have a loop down there anyhow just to make sure. Likewise, we do the same thing with student stuff through another query. We pull everything from enrollments for that course ID, and we select the student associated with that enrollment's full name and create it in this temporary object called student stuff in a field called student. So now we have course stuff that has title, department, and instructors in it, and student stuff which has student in it, corresponding to their last name. So we're then going to loop through this, even though, again, we should only have one. We're going to take the title of the course and put it in our variable associated with the model course name. We take the department and put that, since that's the department name, not the department object, and we put that in the field department name, and we populate the list of instructors with the list of instructors found for that course. We do a similar thing for student stuff, where we take and loop through and add each name of the student to this array, this list of student names. Outputting is very similar. I'm testing to see if there's a value for course name. Other than that, I pull the model course name, the department name, and I loop through the list of instructors. Here I loop through the list of statements. So, two different ways, coming up with basically the same thing. I will rewrite this. I edited it out and attempt to rewrite this in class live because it didn't work so well. And in the interest of time, I didn't want to sit here and troubleshoot it all day. So I canceled that mission rather, and I'll come back and show you possibly a cleaner way to write this code next time. All right, that is all I had for now. If you have any questions, let me know. I will either see you in lab or I will see you next week.